Hello everybody, it's me, RPI boy, and today I'm going to show you how you can make a Raspberry Pi controlled robot. It is going to be controlled via the internet. So let's discuss what we are going to need. The Raspberry Pi 3B or 3B plus or 4, whatever is available. The next thing we are going to need is the PiCamera, because we are going to live stream so that we can control the robot. Next thing we are going to need is the L298N motor controller, 4 motors, and the motors will be connected uh, in a configuration in which the opposite terminals will be connected to each other. Then we are going to need 2 LiPo batteries. These are 3.7 volt. We'll need holder and a way to charge them, and this is the charger. We will need wheels, of course, and a chassis to put everything all in. And also to connect everything we will need some jumpers. So let's begin. This is a simple circuit which allows me to charge the lipos. So here I have connected the positive to the positive of the charging port and the negative to the negative. The positive is further extended to a switch so that we can provide power to our L298N motor controller board. And the ground is directly is connected to the charger, and then it goes to the L298N motor controller. Then the motors, as I had told you, I am using a arrangement in which I need to connect the motors in such a way that the opposite terminals are connected to each other. So I just connected the opposite ends of the motors to each other. Okay, so I will begin with mounting my motors on the chassis. I will just mount these, and so here you can see I have just mounted the motors on the chassis, and I have directed the wires to the place where I am going to connect it to the place where I will be placing my L298N motor controller board. As you can see here, my motors are rotated 180 degree on the x-axis. So now I would recommend you to use thicker wires to connect them because they may get loose and come out of the terminals. You can connect the motors in any direction you require, as they are controlled via the GPIO, and we can always change the configuration of the GPIO in our software. So I have just connected all the wires from the motors, and I have also taken the liberty to start assembling the chassis. I have attached the standoffs to the chassis. Now it is time to connect our battery pack to the motor controller board. So the 12 volt will get the VCC will go to the 12 volt. The ground will be, we will combine the ground from the Raspberry Pi and the battery into one and connect it to the ground port, and the 5 volt input pin will be directly connected to the 5 volt output pin on the GPIO pins, that is the Raspberry Pi. As you can see here, I have just used some electric tape to hold the wires in place. Actually the wires may get loose and come out, so to prevent that I have used the electric tape. So as you can see here, I have connected the 12 volt ground and the 5 volt connectors to the VCC ground and the 5 volt input pins on the L298N motor controller board. Now we are going to attach the data pins, that is the pins that on the input. So I have used 4 jumpers over here. The 4 jumpers directly will connect to the L298N motor controller board, the 4 input pins on the motor controller board. Now we will be needing power for the Raspberry Pi, which will be provided by a generic power bank, as it requires power from the USB type B, micro USB B type charger, the normal charger we use for our phones, mobile phones. So as you can see here, I have assembled the I have just mounted the Raspberry Pi and the power bank, and I have also attached the PiCamera. I have stuck everything in place with double tape so that it doesn't come off. Now you might have noticed that I have not connected the data pins as of now. The data pins will be we will connect the data pins to the GPIOs that we define in our code. So if we have any problems later regarding the direction of motion, we can always switch it inside the code. That way we don't have to change any. So I am going to use a remote desktop app called the AnyDesk. It is a free desktop app for remote desktop app. You can download it on the web. So this is the code. I will post a link to the GitHub, and to connect to the stream you will get a command in the comment. You just have to enter it in the terminal, and you will need the IP address of your Raspberry Pi. You can press Ctrl N on the local network on the VLC, and it will access the local network video stream. After running the program, you can see I can control the robot directly from my computer. So I have mapped the keys W, A, S and D to the input, so that WASD will control the forward, backward, left and right rotation respectively, and the X key will stop it. So as you can see, we have just lost our video stream. This happens sometimes as we the Wi-Fi module on the Raspberry Pi is not quite powerful, and sometimes the CPU gets thermal throttled. So as it is not it is an ARM based processor, it has some limitations. Just restarting the stream on the computer is a very easy way to regain connectivity. You can always use, if you upgrade your network sometime, the lag will also be reduced. You will get all links to the code as well as the command that I'm using here to stream the video directly to the VLC media player on the local network. Thank you everyone for watching. Be safe, stay healthy. Thank you.